Welcome to my YouTube channel. Today's example, we would focus on comparing means with unknown standard deviation, and we would look at a problem from the airline industry. So I'll go ahead and read the question, and we would use our programming to try to solve this question. So it's a two population hypothesis testing with the standard deviation being unknown. So the question says, the success of an airline depends heavily on its ability to provide a pleasant customer experience. One dimension of customer service on which airlines compete is on-time arrival. I think if you've been at the airport, this is very important to us that are flying, right? You want to be able to depart from or leave the departure airport on time as stated on your ticket, right? So that you can arrive your destination on time as well and go about your business, right? So the data set is in a file called flights, which in a minute I'll show you the link to download that data from my GitHub page. It contains a sample of data from delayed flights showing the number of minutes each delayed flight was late for two different airlines, right? So for this exercise, we would be using Delta and Southwest Airlines. And then the first question there says, formulate the hypothesis that can be used to test for a difference between the population mean minutes late for delayed flight by these two airlines. So basically, our mu1 would be the population mean minutes late for Delta Airlines flight, and then but mu2 will be Southwest flight delay in minutes, right? So that's basically how we would define mu1 and mu2. And then we can go ahead to then formulate the null and alternate hypothesis based off that definition. But one keyword I want you to take note of that would help us determine what type of tail our hypothesis, our alternate hypothesis will be, is this word difference, right? A difference between the two population means. So let's go ahead and try to answer question A in R. It's just really simple. We're not doing any coding. We're just formulating the null and alternate hypothesis. Okay, so I have the title for it here, which is comparing means with unknown standard deviation. And then there's the link to the GitHub page to help you download the data called flights data. So you can either type out that link into your web browser and download the Excel file, or in the description of this YouTube video, I will put that link there. You can just click on it and it takes you to the page and you download it, whatever you feel like doing, right? So the first thing we want to do is install the packages and load the library, right? But if you have installed the package before on your computer, you do not need to install it again, right? So basically skip, I think it would be line number 5. Just skip it if you have installed it before. So so if you've installed the read Excel package, right, you just skip line number 5. Do not try to install it again, right? Just skip it. And then you then need to run line number 6. That's the only line you need to run. If you have installed line number 5 before, please take note of that. I'm just going to put a comment here, right? Skip it if so you don't have to worry about that, right? So I'm just going to run only line number 6 because for me, I have installed line number 5 before, right? So that's that. And then the next thing I'm going to do is load my data set, right? So I have it as data, read Excel, file.choose, and that's it. And then I can just say data, just show you guys a different thing here. All right, so let's load that data. Okay, so I have my flights data loaded. So you can see it has 25 observations with 2 variables. So if I click on it on my global environment, this is what I see, right? So I can see my Delta Airlines here on the first column, and I can see my Southwest. And just like the previous video, right, which we did on comparing means with known standard deviation, this one also has 5 rows that do not have any information, right? So we'd also have to clean this data and basically delete all of this NAs because we do not need it. And then you can you can run line number 9. It just also gives you like an output of the data here, right? So that you can see how it looks like and everything. So all right, so now that we have done that, I'm just going to load the data set, right? So let's answer. So I'm just going to have this as question 1, right? Which is null and alternate hypothesis. But before we do that, let's define what mu1 will be. So should I use, no, just use an equal to, right? So mu1 would be the Delta flight delay in minutes, right? And mu2 will be Southwest flight delay in minutes, right? And now we can basically state what HO and HA will be. So HA is mu1 minus mu2 not equal to 0, right? Basically the delay, the flight delay for Delta is not equal to the flight delay in Southwest, right? And then mu1 is going to be that it's equal to. So that's what that means. So now we have all of that out of the way. We've basically answered question number 1, or question A, which is to formulate the hypothesis, right? Part B is now asking us to calculate the sample mean, right? What is the sample mean number of minutes late for delayed flights for each of these airlines, right? So it's very simple. All you just do is calculate the sample mean, right? So let's go ahead and calculate the sample mean. So question 2, let's say compute the sample means, right? But before we compute the sample mean, we have to clean the data, right? Especially the Southwest one. We have to clean it. So clean the data and remove the NAs, right? That's the reason why we're cleaning the data. So basically what I'm just going to do is say I need to have like a new variable called Southwest. And then remember, we use the NA omit to take out the NAs from our data. And then you click $ and just click on Southwest, right? So if I run this in our values area on the global environment, you can basically see that instead of having 25 observations for Southwest, we now have 20 because we've removed the 5 observations that did not have any values, right? So please take note of that. Now we can calculate the the sample means. So let's start with, let's see. I can say SM sample mean underscore delta, right? Maybe I can put it like that. Yeah, sample mean underscore delta. And then we can say data dollar delta, right? And I just like to put the result beside it so everyone can see it. So if I run this, ooh, you can see the sample mean, so 50.6 minutes, right? That is the average delay of Delta flights, right? And then SM underscore Southwest. So now I'm not using the Southwest column present in the data, right? I'm going to call line number 21 instead, right? The one that I've claimed. So we just say Southwest. Run this, and we have 52.8 minutes, right? So you can literally see that the average delay between the two airlines, right? Delta is 50.6, Southwest is 52.8 minutes. So basically, Southwest has a higher delay by 2 minutes and 8 seconds when compared to Delta. But here's the catch. You need to know that they do not have the same sample size, right? One of them has 25, the other one has 20 samples. So you want to take note of that as well, right? So the next thing we want to do now is basically go and answer question number 3. Right, we're done with question number 2. It just asks us to compute the sample mean, right? That's all it asks us to do. So maybe we could put a little bit of interpretation here, just to make it look nice. Let's say the average flight delay for Delta Airlines is 50.6 minutes, and Southwest is 52.8 minutes, right? So that's basically going to be our interpretation. So let's do question number 3, which is using a 0.05 level of significance. That's our alpha, right? It's asking us to do the hypothesis testing now. What is the p-value and what is your conclusion, right? So okay, so now we have to perform the hypothesis test, right? So because we're dealing with the population standard deviation being unknown, right? We use the sample standard deviation to replace the population standard deviation. Basically, we're using the sample standard deviation to estimate the population standard deviation, because the population standard deviation has not been given to us in this question, right? So the right test statistics that we have to use is called the t-test, right? Or the t statistics. That's what we have to use for this problem, right? So here we would say, I'm just going to say t underscore test, right? And then the function would be t.test, right? That's the function that helps us to do that. And then we would call our first sample, which is delta, right? And then our second one, which is Southwest. So we're basically calling line number 21, right? Please remember that, because that's the one that is clean, right? So we're doing paired because we're working with, sorry, we're putting our paired as false because we're working with an unpaired data, right? So that's why we're using paired as false, right? It's not a match sample. That's why we have paired as false. And then the alternative, right? We're putting the alternative as two-sided because of this, right? So take note of that, please. And then our confidence level, those are some of the, so the major parameters you deal with when you're working with the t-test is you have to state your two variables, right? Your first sample and your second sample, or your mu1 and mu2, right? You have to state them out. And then you have to state if it's paired or unpaired, right? If it's paired, you say it's true. That means it's a match sample. If it's unpaired, you say false, right? Basically, the samples are independent. Then the alternative, right? Is it two-sided or one-sided, right? So you have to state that here. In this case, it is two-sided. And then our confidence level is given to us as 0.05. So all you just do is put that. So instead of saying 0.05, you just subtract 1 from it, and it's 0.95, right? Which is 95%. So that's what you would put there. And then finally, you just want to say list bracket test in order to give you the output of the results, right? So let's run line 30. Oh, sorry. List bracket t-test. My bad. All right. So you can see it there. You can see the output, the Welch two sample t-test, right? And you can see our first sample is Delta and our second one is Southwest. Our t statistics value, or t calculated, is a negative number, right? Negative 0.32. And then we have a degree of freedom as 42.9 and a p-value of 0.75, right? It also, I think the nice thing about the t test function here is that it automatically calculates the confidence interval, right? Or the interval estimate. So it automatically calculates it for you, so you don't have to manually do it. So the 95% confidence interval is shown here to us, which goes from a lower bound of -16 to an upper bound of 11.8. And then you can see our means as well, 50.6 and 52.8, which is exactly the same thing, which shows us that, hey, line 23 and 24 is correct, right? We've done it correctly. So now that we have that, we can just go ahead and just basically type out an answer for question number 3, right? Which is asking us what is the p-value. So we just state the p-value there, and then also give our interpretation. So I'm just going to do that. So I could say result for hypothesis test. So p-value 0.05, which is greater than alpha, which is 0.05, right? And we can say we do not reject HO, right? And basically the interpretation for us saying that, because 0.05 is greater than 0.05, 0.75 is greater than 0.05, right? So our interpretation would be that we cannot reject the assumption that population mean delay times are the same, right? So basically, when we say we do not reject, what we're saying is that this is true and this here is false, right? That's what we're saying. So when the population mean delay times are the same, for Delta and Southwest Airlines, right? There is no statistical So what I'm just going to say it in a bit. All right, so there is no statistical evidence that one airline does better than the other in terms of its population mean delay time. So that's basically how we can interpret the results that we have gotten, right? So that takes care of question number 3. And question number 4, the last one, says, what is the 95% confidence interval for the difference between the two population means, right? Remember, everything has been calculated for us in line number 30, right? So you don't have to do a new calculation. All you just have to do is interpret the result, right? 95% confidence interval, right? So I'm just going to say result again, and 5% CI is negative 16.24 to 11.84, right? That's basically your result. And the interpretation would be that because the CI, since we're dealing with two population means, right? This here is going to be, the 0 here is going to be our hypothesized mean. And then we have to check if that 0 falls between these intervals, right? And you can see this goes from negative 16 to 11.84. So because it falls within that interval, right, where our result of saying do not reject HO is actually correct, right? So because the CI contains 0, there's no statistically significant difference between Delta and Southwest delay times. All right, so that's how we interpret the confidence interval. So please take note of this. I hope you practice this example along with me. And thank you for tuning in today and following the entire coding process with me. Please like the video, share it, comment, and don't forget to subscribe to our channel. Till next time. Thank you.